Hello, students checking out the homework for 11-1. So I've assigned 1, then 3 through 16, 18 to 19, and 21. So if you think about it, cut out 2, cut out 17, cut out 20. Now, there are a number of problems here because there's so much terminology that I want to make sure that everybody has that opportunity to make sure they understand how the terminology connects everything together. So as you take a look, you'll be looking at these as true and false. For those of you who are new to the class, these are not true false questions on the test. These will be always, sometimes, never. Okay. So here, instead of this one, I would phrase it as skew lines are coplanar. And you would say they always are, they sometimes are, or they never are. And then you would give an explanation. Okay. All right. Let's see here. So that's question 1. Question 3. Again, this is just about terminology, to be perfectly honest. So grab your sheet that has all those little definitions and say to yourself, okay, I need 3 points that are not collinear. That means they cannot be on the same single line, right? And there are multiple options for this. How many planes are determined by 3 non-collinear points? How many planes are determined by 4 points that are not coplanar? And how many planes by n points? So now we're starting to see a connection. This goes back to the example in the video and in the textbook of I give you 3 points that are non-collinear, how many lines? I give you 4 points, how many lines, right? So now we're taking planes that are determined by, and we're going to make planes. So we're going from 2-dimension to 3-dimension. Question 5, determine whether the symbols name the same geometric figure. So this is about how we write them. Now, if you watch the video, it's already pretty clear. I think if you read the book, it's also pretty clear, but I want you to kind of sketch them out if you need to and say, yes, this is identical, or no, this is not identical. Let's see here. On the dot paper, draw all possible segments that are parallel. Now, if you're on dot paper, remember, parallel does involve the idea of the same direction. So if you take a look, to get from P to Q, you went right 1 and you went up 2. So make sure that any segments you draw go right 1 and up 2. Okay. Let's see your coplanar points, A, B, C, and D, so that no 3 are collinear. Now, this is a good way of thinking about it. I need to create coplanar points so I can think of sketching them on a plane, and they're all on the same plane, so I can have A and B. Now, remember, A and B are guaranteed to be collinear because any 2 points define a line. You could have point C then, just don't pick point C on that line. This would be wrong. Pick point C somewhere else. And then make sure you pick point D so that it's not on any of the lines that could be made when you draw the next one. So if you think A and B have a 1, A and C have 1, and B and C have 1, don't pick D on any of these. Pick point D somewhere else. Then it says how many distinct angles less than 180 degrees would these determine? So if you pick those 3 points, right? How many distinct angles, those are different angles, would we be able to determine? So BAC, this would be an angle less than 180 degrees, right? Based on the way that they're drawn here. But again, if it was bigger than 180 degrees, like if you were thinking, aha, this one over here, just remember you have the reflex angle. So they're kind of using the idea of reflex to figure out how many different and distinct ones we'd be able to create. You'll notice a few of these graphs. Sometimes they draw a 3-dimensional shape for you and then ask you to apply your definitions to this shape. And I know for some of you, this is going to be a little tough, but you'll see right angles. They're trying to draw them specifically. So BD right here is perpendicular to BF. That's what that line means and what that little symbol means. Here you see 2 right angle pieces. Notice they're kind of at a diagonal for one and on this one for the other. So that tells you DH is perpendicular to HG. Okay. They will ask you for the measure of angles at times. They'll ask you to name pairs of perpendicular planes or even parallel planes. They're trying to get you to understand the terminology in action. Okay. Let me make sure. What was the one I said? 3 through 16. Okay, so this is, hey, a pyramid. Fantastic, right? We got a pyramid. We'll learn more about those in 11.4. But for now, as you look at it, you can say, okay, cool, pyramid. What do I know about this pyramid? Well, I've got a 90-degree angle here, which means BE is perpendicular to the plane ADC. Okay. Now they're going to ask you, what is the intersection of segments? What's the intersection of planes? You have to be able to, in your mind, kind of shade those. I know it's a little challenging, but it's a skill we want to develop. Okay. Same down here. Now I want you to think of this like a book that's open. Okay. So it's kind of, there is an angle on one of these sides. And then it's going to ask you, here's plane alpha, here's plane beta. Where do those planes intersect? Okay. Down here, you'll see a union. If I have BD and union BA, where does that intersect? Name the shape. Don't describe it. Try to use the terminology and the symbols that we're learning about. Okay. All right. Let's see here. Determine the number of obtuse angles in the following. Okay, remember an obtuse has to be bigger than 90. All right. And there's many. So be thinking about all the different ways you can make an obtuse. Don't just think that I have to use E. You could also use F as you're doing it. Okay. When it says identify a physical model, think about reality. So if you look outside and you see something, you're like, those are parallel, then give a description, give a verbal description, a kind of a written description of what do you mean by those are parallel. Maybe when you look at a fence that you see, you can see that the lines between the little gaps between the boards, you could say those are parallel. That would be a representation of parallel lines. Up here, this is kind of a circular protractor, and they're just going to ask you to find different measures of angles. So they give you BAC, then I would recommend, at least at first, that you kind of get used to saying, wait a minute, what is BAC? Start at B, go to A, go to C. And now they want to know the measure of this. So you notice this one's at 20, this one over here is at 45. How much is the angle between them? Good use of all of the operations that we've had from prior term. A great one, adding and subtracting in degrees, minutes, and seconds, which is base 60. Pretty much guaranteeing you're going to have one of these on the test. Following measurement is in degrees, minutes, and seconds. Oh, this one's in decimal degrees. Convert it. Put that back into degrees, minutes, and seconds. So again, something that goes forwards and backwards, being able to do that. Then this time, now we get to see, why did we cover chapter 8 before we came here, Scott? Because of questions like this. Because by the time we get to questions like this, I want you to be able to say, wait a minute, I know some things. Like here, if they've labeled something as X, I'm not scared of it anymore. I know from this picture that X plus Y is 90 degrees. I can see that because it's a right angle. And angle AOB, the measure of angle AOB, well, that's X, is 30 degrees less than double the other angle, which is Y. Oh, it's 30 degrees less than 2 times Y. Huh. So could I write that as another equation here? Yes, you could. And now you've got two equations with two unknowns. You can solve it in many different ways. Substitution, elimination. That's why we covered chapter 8, because in geometry, there are connections. The connections create equations, equations that we can solve using algebraic techniques. So for me, when I look at these type of questions, I want to be able to create equations. Here, this first one, right? Notice that's a straight angle. So all three of these things have to add up to 180 degrees. Write it out. There's your first equation. Down here, this is a straight angle. That means they have to add up to 180 degrees. Write it out. And then use the second clue as your second equation. Because without that second clue, you could have had infinitely many answers where one adds to the other to make 180. You could say, aha, they're 90 and 90. And I'd say, oh, okay, yeah, that would work. X and Y. What about 91 degrees? Fine, 91 and 89. Okay, yeah, that works too. But this second clue here tells you, nope, these don't work. There's only maybe one specific group that actually works. Fantastic. Next up, I think I said skip 17. Didn't I? I did. I like 17. Okay, so 18 here. Yeah. That one's practicing drawing three-dimensional pieces. And you're welcome to try it. What you would do is just make sure you use dotted lines for something that's kind of behind. If you need an example of that, let's see here. Those are cuts, so that's not the same. Here. So you see this line? Like if you had an actual pyramid, you wouldn't see it because the face would be blocking it, and you wouldn't see this dashed line back here. So again, it's not bad to practice, but it's just one that um, I struggle with. And I definitely struggle when the shape is already drawn for me. If I have to draw it myself, then I can kind of get there. But we'll deal with that as we go. 18, great use. We've got angles, we've got radius, we've got a diameter, we've got a chord, we've got another chord, we have angles and arcs, and the goal is to be able to measure them using the terminology that we have. Okay, so if it says ACO, again, draw ACO, right? So draw it. Where is ACO? Angle A, start at A, C is my vertex, and then O down here. Got it. Okay. Well, I look at that and I'm like, I have no stinking idea. But when you don't know, call it something, even if it's a question mark. And then notice, what do I see from my shape? There's a right angle there. Oh, so question mark plus 55 degrees has to add up to 90 because it's a right angle. And now I can again use a little bit of my algebra skill, or at least algebraic thinking, to figure out what's missing. Let's see here. This again, very algebraic in nature. If the measure of angle A is 30 more than twice the measure of angle B, and the sum of the measures is 180. Okay, so just start. I don't know what they are. Call them X and Y if you want, and then create equations that you can solve. Let's see, what else did I do? 19, I think I skipped 19. Oh, dang, I skipped that one. Oh, because I gave you the one on the previous page. Number 20, bevel cut, miter cut, rip cut. And I said, yeah, I want you to do this one. There we go. Consider the planes formed by the piece of wood and the plane of the saw blade making, and describe each of those cuts geometrically. Okay, use the terms that we have done, right, to determine what are we actually kind of cutting as we go. And I think that was it. That was the last one that I did. I mean, 21's not bad. Yeah, so angle of depression is just when you're looking down. Angle of inclination is if you're looking up. We'll use that again later, but I didn't see true purpose for it here. And that's it for the homework. All right, hope you go. Again, a lot of terminology. I know that. I'm going to try to use the terminology in class, and every time I do, I'll give the term, and then I'll try to throw in kind of what that means so we can get used to it. All right, off you go.